Hello everyone, welcome back to my channel, and today we are gonna be talking all about Pipecat data frame. So if you remember, in the last video we talked about Pipecat system frame, what exactly is a frame, then we talked about system frame, the high priority, low priority, and today we are gonna be talking about data frames. So I will just be showcasing one diagram which we saw in the previous video. So we have frame as a base class, then we have system frame, data frame, control frame. System frame is the highest priority, and data frame and control frame are the low priority ones. So today we are going to be talking about the data frame. So let's get right into it. And here data frames are something, as we discussed, which is low priority, but it is strictly ordered, and they are mainly designed for streaming and real-time systems where the core is data carrying units in Pipecat pipeline. So this is the core data carrying unit in Pipecat pipeline, and this is in contrast to control frames. We'll be discussing control frames in the next video, which alter the behavior of the processor, or which alter some behavior, but here it is just carrying the data. So given we have different kinds of data involved, like we have different kinds of data frames. So we have text frames, audio frames, image frame, LLM context frame, function calling frames, transcription frames, and there are other data frames. So these are they allow text, audio, images, and context to move through the system in order. And Pipecat developers building voice AI agents, multimodal assistants, or real-time AI systems uses these data frames. So yeah. So next, let's see what are the different text frames. So here are different 8 types of text frames that we have. So we have text frame, LLM text frame, transcription frame, interim transcription frame, aggregated text frame, TTS text frame, vision text frame, and translation frame. So we have different types of models involved. We have vision model, translation model, then TTS model, then aggregation processors, and then some transcription frame for STD, and frames for LLM. So these are the different frames that we have. So next we will be seeing first the text frame. So this is the generic text frame. It provides a simple, flexible way to inject or transform text in the pipeline. So it is used for manual text injection, text pre-processing, or text post-processing, and some it is mainly for non-LLM generated text. And these are the different properties, like text skip TTS, whether we want to skip the TTS or not, and whether the interframe spaces are included or not. Interframe spaces are basically in the text, the spaces that we have. So one text frame followed by another text frame, do they have the spacing or not? So generally when we are generating the text manually, we always keep the space included by ourselves. So this is set to as like false, and we are appending to context, like whether we want to append to LLM context or not. So by default it is set as true. So, and this is used by developers building custom processors or middleware. So we have already discussed that. So these are the different key points that we need to keep in mind. And this is a working example where we import a text frame, we create a text frame with this text, and we can adjust the properties, skip TTS, for the append to context true, and all of that, and then we can push this frame to the processor. So this is the text frame. Then we have LLM text frame. So LLM text frame is like text generated by LLM services. It is useful when we want to represent authoritative output from an LLM, and this is automatically includes the interframe spaces. So in the last text frame we discussed, text frame is generally does not have interframe spaces. Our LLM output, we always keep include the interframe spaces. So just to give you an example, like we import the LLM text frame, then LLM text frame, we have this text, I'm an AI assistant, which is generally given by the LLM. And these interframe, like I'm an assistant and let's say the next text is how can I help you. So it already includes the interframe spaces. If it did not had the interframe spaces, like it was set to false, then it the whole thing, I'm an AI assistant, how can I help you, this will be whole one thing. And it might the our TTS engine might not take a pause between after the assistant and how can I help you. So if interframe spaces are there, it might take a small pause to make it sound natural. So this is the LLM text frame, and generally LLM services and LLM adapters output this. So it is used by them. Next, we have transcription frame. So, transcription frame is kind of like a final STT result. Whatever speech our STT service is receiving, and it is converting all the speech to text, and this that text is kind of like a transcription frame. The whole transcription of what the user spoke. So it acts as the user input for the system, and it derives the LLM response. So it is creating, building the context what the user has spoken, and now we can feed this transcription frame to the LLM to know like how what to respond. So these are the different properties for text frame, transcription frame, and we can use it like after importing. We can just describe the transcription frame, text, user ID, timestamp, language, and all of this, and we processor uses this and push it. So key points to note: it contains metadata like language, timestamp, confidence. We can see this, and also we appended to like a aggregator, and we also added to LLM context, and this marks the end of the user utterance. Next, we have interim transcript frame. So generally, when the transcription is being done, like sometimes we want to show few things on the UI what the user is speaking. So we create interim transcription frame where before sending the final result to LLM, if you want some interim transcription to be shown on the UI, then we can have this frame to give the feedback to the user what user is saying, what our STT service is capturing. And once it is done, like we create the full transcription frame and send it to the aggregator and LLM context. So you can see interim transcription frame would somewhat look like this: hello, how, and then there will be another interim transcription frame which will argue like that. And this is a full transcription frame. So this is the interim transcription frame. Next we have aggregated text frame. So aggregated text frame is mainly used by aggregators. So generally, when the user is speaking, we don't want to everything to be sent to LLM directly. We want to get all the different responses from the user. Sorry, the input from the user, and once we create all of those aggregated text, we output the aggregated text frame. Okay, this is the whole thing that the user has spoken, chunked by words or chunked by sentence. So we can have different aggregation strategies which we will be seeing in when we'll be talking about processors. So we have different kind of processor. So aggregator is one type of processor where we aggregate the text by a sentence and words, and we create this aggregated text frame. So this would be like a full sentence: hello, how are you doing today, something like that. So this is the aggregated text frame example we imported, and this is the full text, and this is aggregated by sentence. So yeah, so this is aggregated text frame, and it improves the TTS quality and latency because it is converting many small text chunks into coherent unit. And next we have TTS text frame. So TTS text frame, as the name suggests, it explicitly marks a text as ready for speech synthesis. It is used right before when a text is sent to a TTS engine. So it is mainly used by TTS services and speech pipelines. And here we have one example where we have TTS text frame and hello how you aggregated by sentence, and then we are pushing that. So aggregated text frame, then TTS text frame, and then TTS services. When it receives this TTS text frame, it becomes clear to TTS service to start its own some internal processing and then do the next step. So this is kind of the starting frame for TTS service. Next we have vision text frame. So we have different kind of models. So let's say we are using any vision models where we are giving any image to our model, and then we want to out, and along with some prompt, what does that image represent or something, and now LLM is reading that image and then giving us some output via speech. So we can have some vision text frame for that, where we can mention the text, I see a cat in the image, something like that. So it brings vision model insights into the text pipeline, and mainly it is used for after image analysis or visual understanding for multimodal reasoning. And yeah, so this is mainly treated like a LLM generated text and can feed directly into LLM context. Next, we have translation frame. So sometimes when we are speaking in different languages, so we wanted the transcription frame to go through a translation service to give us some translation output. For example, this is some text in some other language, and Spanish language, and we want it to be converted into English. So we send the translation, we create this translation frame, and which will give us the output in some other frame. So this is a translated transcription frame, how it is used. And then next we have different types of audio frames. So until now we were discussing about text frames. Now we have audio frames, where we have generally audio frame with respect to data frame. So we have three different types of data frame in audio frames. So we have output audio raw frame, and then we have a TTS audio raw frame, then we have a speech output audio raw frame. So first coming to output audio raw frame, it's kind of like a output data frame for output to transport. It is the final step for delivering audio to the user, and it is used when audio is ready to leave Pipecat. So it is received by transport layers to send it to the user. And some points to note, it's like we can specify the destination transport. It is transport agnostic, and it marks a boundary between processing and delivery. So we have one example where we are importing output audio raw frame, and we are giving the audio byte sample rate, number of channels. So this is something, number of channels is like generally for voice agent it is one, like when we are calling on a call with voice AI agent, so number of channels is one. But if there are many users involved, we are many people are speaking, then we have multiple channels, number of channels is more. And the number of frames is calculated automatically based on number of channels and sample rate, I believe. So yeah, so this is something that generally how we define output audio raw frame, and we are also defining transport destination, which speaker to speak, and then we are processing it like by pushing it. So TTS processor output audio raw frame, then transport, and then user. So this is output audio raw frame. Then next we have TTS audio raw frame. So TTS audio raw frame is like a audio generated by TTS service. So this is one example. So we receive this, we import this TTS audio raw frame, then this is how we define it, and then processor pushing this TTS audio raw frame. So one difference between output audio raw frame and TTS audio raw frame is like sometimes in the end after TTS we have some processor which receives this TTS audio raw frame, and it converts that frame into output audio raw frame. So next we have a speech output audio raw frame. So speech output audio raw frame is like when audio frame when we want to differentiate between speech and silence. So it enables better stream control, and so as the name suggests, it is audio frame part of continuous speech stream. So distinguishing speech from silence in audio stream. It is mainly used by TTS engines, and it helps transport manage buffer. So how much memory? So when we will be discussing about the processors, then we have one different kind of processors involved. So in that we will be discussing about more about how we distinguish speech from silence a bit. And about buffering. So that is sometimes when this speech output audio raw frame is useful, and yeah. So next we have different kind of image frames. So we have output image raw frame, URL image raw frame, sprite frame, assistant image raw frame. So I'll be just covering them very briefly, just to cover what are the different image frames. You can look into details how it works and everything. So output image raw frame, as the name suggests, this is the output image frame with the data, and it has the image data frame for output to transport, and these are the properties of the image size, format, and transport destination. Here is one example where we import this, we define it, and we send it via the push frame. So this is similar to audio. This is output image, then we have URL image. So along with the image we have the URL data. So same as everything, apart from that we have this URL image as well. And then next we have sprite frame. So let's say we have multiple, sometimes we want animated images. So we have different frames, and we create this animation out of all of these frames on loop. So it is output image raw frame, like we have different output image raw frame, and then we create a sprite frame out of that, and then we push it. So this is the sprite frame, and then assistant image raw frame is image generated by assistant for LLM context. So similar to other image frames, we have this assistant image where we have the image details along with other data like original mime type, original data, and all of these details. So this is the assistant image raw frame. So now in LLM we have different kind of context frame. So we have 8 kind of context frame. So LLM context frame, LLM run frame, and all of these LLM context frames that you can see on the screen right now. Message update frame, messages append frame, set tools frame, set tool choice frame, configure output frame, enable prompt caching frame. So I've not used all of them, but I'm just gonna cover very briefly for you to understand what are the different LLM context frames that we have. So starting with LLM context frame. LLM context frame purpose is universal LLM context for generating responses. So when we have a context aggregator, so we will be discussing about different processors where we will be having aggregator processors as well. So context aggregator is one of them, and which output LLM context frame, then which is used by LLM service to create the response. So our LLM service would need some kind of context to create responses in better way, like some history of the conversation for LLM to know what's actually happening, so that it does not start from scratch, kind of like memory. So this is the LLM context frame we have. We create this LLM context, the messages, and then we push it the context in the LLM context frame, and then we push the frame. Then we have LLM run frame, which trigger LLM to process current context and generate some response based on that. So based on whatever context it has, and it will trigger some output. Like we want maybe sometimes, if you remember in the example we talked about in the first video, where we want, when the voice call starts, we want the LLM to say something, give an introduction. Hey, I am an AI bot, and how can I help you? Something like that. So we want the LLM to trigger first. So we use this LLM run frame. Then we have LLM message update frame. So let's say we want to update the message fully. We want to replace current LLM context messages. We can use this LLM messages update frame to update the context. It is as simple as this. Like you can see the example. We have some new messages. We are not appending. This is updating the full messages. So yeah. So this is the LLM update message update frame. Then we have messages append frame, which is if you remember, the all the context that we have. If you want to append to that context, so this is the LLM messages append frame, which append to that context. And then we have set tools frame, where in case we want to define certain LLM function for calling it, and like generating some uh, result out of it. So we have this LLM set tools frame, where the tool that we are defining it, like the function name, description, and other parameters, and then we call this LLM set tools frame. Next we have LLM set tool choice frame. So configure set to configure tool choice behavior. So you can see we have different tool choices, and we are giving the LLM whether this tool is required or not. So yeah, so this is if we can give it like a specific tool, for example, this tool choice function, and get whether, um, so it forces LLM to use a specific tool. Then we have a configure output frame. uh, if you want to configure LLM output behavior, maybe sometimes you would want to have output in JSON, or maybe something like skip the TTS, then we can use this. So it configures the output behavior based on LLM output. Then we have LLM enable prompt caching. So sometimes you would want to cache a certain prompt, so we can use this, and enable and disable it. Next we have function calling frames. So if you remember, in system frame we have certain function frames. So here we have for data frame we have function called result frame, where once we call this, we have made a function call. So whatever result we have gotten, like we got this result using this frame, so function called result frame. So in the processors, generally we would be creating certain result via this. And just to note, this frame is uninterruptible. So let's say if there is any interruption or something, then all the frames are dropped, but this frame is not dropped because this is uninterruptible. Next we have transcription frames. So we already discussed about one of the transcription frame, but That was a text frame. Now this is transcription update frame. So we want to, let's say, um, uh, we want to add certain new messages to the conversation transcript. So we can use this transcription update frame to make changes to the conversation transcript. And we are appending this messages and pushing the frame. So next we have other different type of data frames: TTS speak frame, output transport message frame, and output DTMF frame. So I'll be just going through them, discussing very briefly. TTS speak frame is text that should be spoken by TTS, so something like that, like text, and push frame, and this will be spoken by TTS. Then output transport message frame. So we are importing this output transport message. What is that event and value, and then we are processing it. So whatever message data that we have received, and uh, output to transport. So this is output transport message frame. Then we have output DTMF frame. It is kind of like a, in the keyboard we have different key presses. So if you want to output those DTMF keys to output transport, so we can have this output DTMF frame for that. So basically this output frame is for processing it out of the pipelines. So these are the different frames that we have. Next, I'll be showcasing one complete data from example that we generally use on day-to-day basis. So generally, first you can go through this code. You can pause the video and go through this manually. But I've created this next slide where we have all the main details. So we have this STD transcription, then which is used by aggregators to create the context. Then it is triggering the LLM, then LLM respond, then we have TTS input, TTS does something, then TTS output, then output to the transport. So we have all these different frames involved, like transcription frame, LLM context frame, LLM run frame, LLM text frame, TTS text frame, then TTS audio raw frame, and then output audio raw frame. So in between there are multiple other frames that are involved, but this is the general flow looks like. And there are other frames which we either inject manually or some other services using them internally. So this is I've described all the different data frames. And one more example of the same flow is like we have STD aggregator LLM. So transcription frame aggregator is using this LLM context frame, LLM is using LLM run frame, then text frame, then text TTS text frame, and then output audio TTS audio raw frame, and which is kind of like a output audio raw frame in between. It will be used by something, and output audio raw frame is received by transport, which will be sending the audio. So that's all we had in data frames. So so just to talk about why these frame design matters, like we have strong separation of concerns, like this is team friendly and real-time safe, and it is extensible across different modalities. So yeah, that's all we had, and in the next video we'll be discussing about control frames. So see you in the next video. Thank you.